students, good morning to one and all.
Good morning, madam.
So, in the previous classes, we have learned many things about which chapter? Yes, regarding the rational numbers, isn't it? So, we have solved many examples and as well as the exercise problems of 8.1. So, today we are going to do some more problems in the exercise 8.2. So, before solving the problems, so we have learnt about, yes, the operations on the rational numbers. Have you remember, students? Yes, this complete exercise is also gonna be what regarding the operations on the rational numbers. So, if you are well versed with the operations on the rational numbers, then we can easily solve the problems here. So, what are the operations for basic operations we have learned? Yes, that is addition, subtraction, multiplication and division. So, how we have performed these four operations on the rational numbers? On the rational numbers, we have, yes, solved few example problems in the previous class. So, now let us do the exercise problems. Yes, in the exercise 8.2, what is the first question, students? Find the sum. Find the sum of, what is the first bit? What is the rational numbers they have given? So, 5 by 4 plus of minus 11 by 4 is the question. So, what is the question they have given? We have to find the sum. Sum is what? Yes, we have to perform the arithmetic operations, that is addition. One of the arithmetic operation, what? Addition for the given two rational numbers. So, what is the rational number? 5 by 4 plus of minus 11 by 4. So, students carefully observe here. So, here they have given plus and bracket minus 11 by 4 and bracket minus 11 by 4, isn't it? So, we have to first take the symbol outside. That means we have to take the brackets, right? So, how do you do? 5 by 4 plus into minus is what? Minus, right? Minus 11 by 4. So, now we have to perform the operation whatever we got. Now we have to perform the operation whatever we got here. So, what is the denominator? We have the common denominator, isn't it? So, what is the denominator we have? 4. And numerator we have to write as it is. That is 5 minus 11. So, what is 5 minus 11, students? Yes, it is 6, right? Minus 6 by 4. So, you have to check the sign as well. So, sign is, yes, greater for the greater number, right? That's the reason we have written minus 6. So, minus 6 by 4 is the thing we got. So, can you do more simplification for the given answer? Yes. So, this is multiple of 2 3s are 6, 2 2s are 4, isn't it? So, what is the answer we got? Minus 3 by 2. Okay? Clear, right? So, what is the sum of? Yes, therefore, 5 by 4 plus of minus 11 by 4 is equals to, what is the answer, students? Yes, it is minus 3 by 2. Clear, right? So, this way you have to perform the operation, arithmetic operation, that is addition we have done. So, let's solve more examples. Yes, what is the second question they have given? 5 by 3 plus 3 by 5. Right? So, we have to add 5 by 3 and 3 by 5. So, how do you add? So, if you see here, the denominators are not same. So, when the denominators are not same, what I have said? Yes, you have to take the LCM of the denominators. So, the LCM of, what are the denominators we have here? 3, 5. What is the LCM of 3 and 5? 3 5s are 15. Yes. So, LCM is what? 15. That is, we got the common denominator now as 15. So, for the first rational number, 15. Denominator is 15, isn't it? So, here we have 3. 3 is how many times 15? 3 5s are 15. So, now we have to multiply 5 into what? 5. 3 into 5. 3 5s are 15. 3 5s are 15. 5 into numerator, what we have already? We have 5. Right? So, this is the first rational number. Next, the other rational number, we have 5. And what is the denominator we got? 15. So, 5 is how many times 15? 5 3s are 15. Right, 5 3s are. Right? So, 3 into, what is the numerator we have here? 3. Okay? Arithmetic operation what we have? Plus. So, how do you simplify this? 5 5s are 25 by 15 plus 3 3s are 9 by 15 is common. And what is the numerator you have? 25 plus 9. Yes, 25 plus 9. How much is the answer? 25 plus 9? 30? 34, right? 34 by 15. So, 34 by 15. So, can you further simplify 34 by 15? No, because here we can see that both cannot be taken for a common multiple. Okay. So, therefore, what is the answer, students? Yes, 5 by 3 plus 3 by 5 is equals to 34 by 15. So, this is the solution. Clear? Let's take fourth problem in this. Minus 3 by minus 11 plus 5 by 9. So, students carefully observe the question given minus 3 by minus 11 plus 5 by 9. Okay. So, how do you do this? Yes, minus is same for both of it, right? So, can you cancel out directly? No, don't do now itself. Okay. So, let's solve. So, 11 and 9. So, what we have to do first? LCM. Because both the denominators are not same, right? So, 11 and 9. LCM of 11 and 9 is how much, students? 11 9s are 99, right? So, yes, 99 is the denominator. 11 is how many times 99? 11 9s are. So, 9 into what we have in the numerator? 3. And you keep as it is the symbol, right? Next, what is the operation you have? Plus. Again, denominator is 99. 9 into how many times 99? 9 11s are. So, 11 into numerator what you have? 5. So, now you got this, right? So, after this what you have to do, students? Yes, here now you can cancel minus and minus, right? So, what is the common denominator you got? 99. And here 9 3s are 27 plus 11 5s are what? 55, isn't it? So, 27 plus 55, how much? 50, 60, 70. 77, 82. Yes, 82 by 99. So, therefore, minus 3 by minus 11 plus 5 by 9 is equals to what? 82 by 99. So, this is the solution for the, yes, given problem. Let's see the next. Yes. Minus 2 1 by 3 plus 4 3 by 5. So, this is the seventh problem, seventh bit. So, students, we have to find the sum for the given minus 2 1 by 3 and 4 3 by 5. So, if you see the given rational numbers, are they in the proper fraction? No, they are in improper fraction. So, how do you convert into the proper fraction? Yes. So, 3 into 2, right? So, 3 into 2 plus 1, right? So, this minus keep it aside by 3 plus 4 into 5 plus 3. 4 into 5 plus 3. By denominator is 5. So, now how do you do? Minus 3 into 2 is 6. Minus 6 plus 1 by 3. Plus 4 5s are 20 plus 3 by 5. So, how do you do this? Minus 6 plus 1 is minus 5 by 3. Plus 20 plus 3 is 23 by 5. Yes. So, if you see, now both the denominators are not same again. So, what you have to do? Yes, take the LCM now. So, after converting into the proper fraction, then you have to take it into LCM. LCM of what? 3 and 5. So, 3 and 5 is what? 15, right? So, how do you do? 15, 3 5s are 15. 5 into minus 5. Plus, again 15, the second term, yes, 5 into how much times is 15? 5 3s are 3 into 23. So, 5 5s are how much? Minus 25 by 15 plus 23 into 3 is how much, students? 3 3s are 9. 3 2s are 69. So, 69 by 15. So, if you observe clearly, denominators are same. So, now you can clearly add up. Minus 25 plus 69 by 15. So, 69 minus 25 is what? You can do in the rough work, okay? 69 minus 25. 4, 6 minus 2 is 4, 44. So, this is what? Plus 44 or minus 44? So, obviously it is plus 44, right? Because the sign here is for the greater number. So, 44 by 15. Okay? So, this is the solution for the given question. Clear, right? So, the first bit is all about doing the, yes, performing the addition, that is performing the operation of sum for the given rational numbers. Clear, right? Let's go for the second bit. What is the second bit? Yes, find first bit 7 by 24 minus 17 by 36. So that means directly they have not given anything. Do the arithmetic operation like subtraction or addition, they did not mention. Directly by seeing here, we can clearly identify that it is a subtraction operation, right? So what you have to do? The same thing. So 7 by 24 minus 17 by 36. So here we can see that the denominators are not same. So what you have to do? Yes, LCM of 24 and 36. So how do you do LCM of 24 and 36? Yes. 2 ones are 2 twos are 2 ones are 2 eights are 16. 2 six are 12, 2 nines are 18. Next 3 twos are 6, 3 threes are 9. So this is 2 into 2, 4. 4 threes are 12. 12 into 2 is 24. 24 into 3 is how much, students? Yes, 4 threes are 12, 3 twos are 6, 7. So 72 is the LCM. Okay. So what is the LCM? 72 is the LCM. So now denominator is what? 72 LCM. So 24 is how many times of 72? 24 into 3, right? 3 twos are 6. Yes. 24 is 3 times of 72. So 3 into 7 numerator. Next minus the next number is LCM, what we got? 72. So 36 is how many times of 72? 2. 36 twos are 72, right? So 2 into 17 numerator. Next 7 threes are how much? 21 by 72 minus 17 twos are how much? 34, right? By 72. So now we see that now the denominators are same. So clearly you can perform the given operation. So 72 is common. So 21 minus what you have? 34. So what is 21 minus 34, students? Yes, you can do here. Yes, 4 minus 1 is 3. 3 minus 2, 13. So we got 13. But here what is the sign? Negative sign is for greater number. So you have to, yes, put negative sign. 13 by 72. So this is the answer we got. Can we further simplify the given answer? Minus 13 by 72. Yes, because 13 is how many times 72? 13 5s are 5 3s are 15. 5 1s are 5 6. 13 7s are 6 jar. 6 1s are 6 7. No. 13 6 jar 78. No, we cannot do. So this is the final answer. Minus 13 by 72 is the final answer for the given rational numbers, that is 7 by 24 minus 17 by 36. Clear? Let's solve. Yes, let's do the fifth bit. Okay, minus 2 1 by 9 minus 6. So if you carefully observe, this is in the mixed fraction. So this is in the mixed fraction, right? So how do you convert into the mixed fraction into the proper fraction? 9 twos are 18. Minus 18 plus 1 by 9, right? So this is what? Minus 17 by 9. So minus 17 by is all this. So minus 17 by 9 minus 6 is the question. So now we don't have anything. So anything means we can write by 1, because always the rational fractions, always the rational numbers will be in the P by Q form, right? So now we have 9 and 1. So what is the LCM for 9 and 1? 9. 9. Next 9 ones are 9. 1 into minus 17 minus this is 9 again. 1 into 9. 9 into what we have already? Yes, 6. Yes, 9 into 6. So 1 into minus 17 is minus 17 by 9 minus 9 6 are 54 by 9. So common we have, now we got the common denominator, that is 9. So we have minus 17 minus 54. So minus 17 minus 54 is nothing but what? We have to do addition, right? Minus 54 minus 17. 7, 11, 5, 6, 7. So that means addition. This we got as minus 71. So what is the answer? Minus 71 by 9. Clear, right? So this is the mixed fraction. We have to solve into the proper fraction and then we have to perform the given operation. Clear? Yes, let's solve the third question. What is the third question, students? Find the product. So find the product for the given rational numbers. So first one, what they have given, 9 by 2 into minus 7 by 4. So how do you perform the multiplication operation for the rational numbers? It's simply by multiplying the numerators and by multiplying the denominators, isn't it? So 9 sevens are how much? 9 into 7 minus 7, 54. Sorry, 9 sevens is 63, right? So 9 into 7 is 63, numerator. And directly multiply the denominators. 2 into 4 is 8. So what the answer is? 63 by 8. Can you cancel out, students? No, right? So this is a final answer. Let's do the second. What is the second bit? We have 3 by 10 into minus 9. Okay? So don't get confused that they have given only a single digit number. This we can directly imagine as minus 9 by 9. Minus 9 by 1. Okay? So multiply the numerators now. 9 into 3 is how much? Minus 27. By 10 into 1 is 10. So this is what? Minus 27 by 10. Okay? Let's do the next. Sixth bit. 3 by minus 5 into minus 5 by 3. So students, so if you see, carefully observe, this negative symbol is given for the denominator. So what I have said, the negative symbol can be brought up to the numerator, that is minus 3 by 5. One and the same, right? Minus 5 by 3. So how do you do? Yes. So directly here, if you carefully observe, we can directly cancel out, isn't it? So 3 ones are 3 ones are, 5 ones are 5 ones are. Okay? Or else if you get confused, then definitely you have to cross multiply. 3 5s is what? 15. Minus into minus is plus. 3 5s are 15. By 5 3s is how much? 15. So 15 ones are 15 ones are. So what is the answer? 1. Directly you got 1. So here itself you can directly cancel out, or else you can multiply it and you can cancel out. Okay? Clear, right? Okay. Yes. Let's do the final fourth problem. Yes. That is which operation now? Yes, division. Very good. Find the value of first bit they have given minus 4 divided by 2 by 3. So what operation is this? This is the division operation we have to perform on the rational numbers. So here minus 4 they have given. That means we have to take it as minus 4 by 1, isn't it? So minus 4 by 1 divided by 2 by 3. Generally, how you will do, children? Minus 4 by 1 by 2 by 3, right? So this is a very complicated process. So what you have to do? We have to do the multiplicative inverse. Here we have to use. That is how you will do? Minus 4 by 1. What is the multiplicative inverse of 2 by 3? Yes. Into, it happens 3 by 2 it will become, because we are changing the sign, right? So into 3 by 2. So what it is? Minus 4 3s are 12 by 1 2s are 2. So can we further deduce? Yes. 2 1s are 2 6 ja. So what is the answer? Minus 6 is the answer. So directly instead of doing this way, this is a very complicated one, right? So minus 4 by 1. Again you are going to write how? Minus 4 by 1. This you have to bring it up. Again it happens 3 by 2. Okay, you will get confused in this way. So better what you have to do? Here itself, after doing this step, you have to do the multiplicative inverse. Clear? Yes. Let's take another problem. Third bit. Minus 4 by 5 divided by minus 3. So now say me the steps. Minus 4 by 5 divided by, yes, minus 3 is minus 3 by 1 you can take. So what I can do? Minus 4 by 5. Now what we have to do? Multiplicative inverse. Into what happens? 1 by minus 1 by 3. Right. So now minus into minus is what? Plus. Next 4 into 1? 4 by 5 into 3 is what denominator? 15. Yes. So 4 by 15 is the answer for the question. Let's do the next. Yes, sixth bit. Minus 7 by 12 divided by minus 2 by 13. Yes. So if you carefully observe, you have to be cautious about the symbol, students. Okay, do not get confused. Minus 7 by 12 and multiplicative inverse, what we can do? Into minus 13 by 2. Can I write this? Yes. So now any cancellations here itself you can do, right? So yes, no more cancellations. So minus into minus is plus. 13 into 7. Sorry, 13 into 7 or 7 into 13. Anything is okay. By 12 into what? 2. Now 13 sevens is how much? Yes, 91, right? 13 sevens are 91. By 12 twos are 24. Isn't it? So this is the final answer for the given question. Okay. Yes. So these are all the operation problems what we have solved in the exercise 8.2. Hope you have clearly understood about each and every problem, isn't it, students? So in this chapter overall, the conclusion what we have discussed about the things, let us discuss in points, right? So first thing we have discussed about the chapter what? Rational numbers. Before discussing about the rational numbers, we have identified what all the numbers that have been categorized into the, yes, the number system. Okay, so first what we have discussed regarding the natural numbers, which starts from 1, 2, 3, so on, we know. Next, what are the whole numbers? When we add 0 to the natural numbers, then we are going to get the whole numbers, that is 0, 1, 2, 3, so on. Next, what are integers? Integers are nothing but these are the numbers which include both positive as well as the negative numbers, that is minus 3, minus 2, minus 1, 0, 1, 2, 3, so on. And next category is nothing but we have learnt about this chapter, that is the rational numbers. So what are rational numbers, students? Yes, rational numbers are the numbers which are denoted or defined in the P by Q form, where P and Q are integers and Q is not equals to 0, isn't it? So in the rational numbers we have seen equivalent rational numbers. So what are equivalent rational numbers? That means nothing but we are going to equalize the given rational number by multiplying into any non-zero number, that is into 1, into 2, into 3 or so on, right? Next, after equivalent numbers, what we have learned? Yes, we have learned about positive and negative rational numbers, right? Positive is nothing but they are going to be positive. Okay, numerator and denominator is going to be positive sign. And negative rational numbers are, yes, both numerator or denominator, anything, any one of it is going to be in negative form. Clear? And we have also learned how these rational numbers will be identified on a number line, right? So obviously we are going to take the right side as, yes, the right side number line as positive numbers and left side numbers are negative numbers. Clear? And we have also learned how to, yes, identify the given particular rational number on a number line, isn't it, students? And then we have also learned about the operations on the number, the operations on the rational numbers, right? So what are the operations? Addition, subtraction, multiplication and division. And also we have learnt about the inverse. Clear, students? This is what all about the complete rational numbers, which is a very, very important chapter for your basics. Okay, hope you have understood. Thank you, students.